Hi, it's Dave. Welcome. Today I'm joined by James Douma, and we are going to discuss the latest Tesla FSD Beta release notes, trying to get a sense of the improvements that Tesla is making with Tesla's FSD Beta. And then we're also going to talk about Andrej Karpathy, Tesla's former head of AI, his recent interview on Lex Fridman, where he gives a bunch of interesting comments I wanted to get James's insight and feedback on. James, welcome back on the show. How have you been?
Been great. It's great to see you
Great.
again.
Awesome. Yeah. Diving straight into it, Andrej Karpathy. So he was asked why he left Tesla as the former head of AI there. And he was saying he got kind of more into this managerial role. He wanted to be more technical, kind of learning and teaching as well. And that he could come back to Tesla at a later point. What was kind of your kind of initial reaction when you heard that?
Yeah, it's a pretty common story, I think. I went through similar things myself at some jobs where you, if you're good at something, one way to like make a bigger contribution to the organization is you leverage yourself by essentially putting together a group and sharing expertise and providing guidance and that kind of stuff because you become leveraged because you're making a bunch of other people sort of better at it. But the more you do that, the more you're not spending your time doing technical things. You spend all your time organizing a team. And in Andre's case, like apparently his team grew to 1,000 people, which is pretty amazing for somebody who didn't start out as a manager. But yeah, at some point you just don't do technical stuff anymore. And if you really like doing technical stuff, I mean, you don't just miss it because you like doing it and you're not getting to do it. But you all at some point you start feeling rusty too, because being a technical expert means you have to constantly learn new stuff, right? Especially in a field like machine learning. So like, yeah, I'm not at all surprised that was
Yeah.
his motivation for moving on. And
Yeah.
it was great to hear him say that he liked working at Tesla and he'd go back too. I mean, it'd be cool if he went back and all that kind of stuff. But the fact that he enjoyed the experience, like he didn't leave with a bad taste in his mouth. It wasn't like, he
Yeah.
got worked to death or that, the deadlines were killing him or something like that. He
Yeah.
just, didn't get to do a lot of the stuff he really loves doing. And so he took a break.
Yeah, yeah, it makes sense. I mean, yeah, I was glad to hear he loves Tesla, he loves Elon, he loves the team. It makes it kind of more unlikely he'll go to like a competitor like Waymo or something. um, yeah.
Yeah, that's not going to happen. I don't see that going that way.
Yeah.
Just, I suspect that philosophically,
Mhm.
the way he thinks about the problem isn't consistent with the way, like if you were thinking about other companies doing it. I'd say Karpathy was a really excellent fit for the job that he was doing at Tesla, not just because like he had the technical chops to bring a lot of skill to it, but because like my read of his sort of expectations about like what the right way to do a problem in using neural networks in machine learning today is a lot more consistent with Tesla's approach to doing it than it is to most other entities out there. There are
Sure.
probably a few, but in one of the things that he emphasized a couple of times is, and this is a very Karpathy take, is data really matters. Like having a
Hmm.
lot of data and really massage. In fact, his role at Tesla, like we tended to think of him as the guy who was inventing the neural networks, but the way he describes his job is, he was like really his job was to like figure out how to gather the data to make a really good training set, and that
Hmm.
they, from that perspective, like the architecture and stuff, that was kind of secondary. Not secondary in that it's not important, but secondary in that that was easier part. The hard part was building the training set. And so the data engine, like that's a core concept that he worked on. It's something he really emphasizes. So where else is he going to go where you could build a data engine, right? I mean, Tesla's the only
That's
entity
true.
out there that's got a fleet that can build the kind of data that Karpathy seems to think is what you really need to do the problem right.
Yeah, yeah, it makes sense. So when asked about timeline for FSD, um, he made an interesting comment that Karpathy thought the problem was tractable. And
Mhm.
what do you get out of that? So my kind of take was that Karpathy is looking at this problem as it's solvable. He sees a kind of a clear path for it to be solved. It's just a matter of time. He's unclear in terms of what's going to take longer or shorter, but he looks at the progress. He looks at the path ahead, and he's like, yeah, this is a solved problem in the sense of it's solvable, right, in time. So, I mean, what's your take on this kind of comment from Karpathy?
There were a number of things that Lex asked Karpathy, which are the kind of pointed questions to like get you to take a position between on one of two
Yeah.
sides of something that is like a divisive topic in the space. And on all of those, Andre declined to, get shoehorned into the whole thing. Like, what about lidar? What about sonar? Those kinds of questions.
Yeah.
And I feel like saying it's tractable is a way of saying, oh, it's going to work. Like, it's totally the right way to do it, without saying those other guys are wrong. Right?
Yeah.
It's like, yeah, it's going to work. It's going to work, right? I believe it's going to work. I think Andre must believe it's going to work. And saying it's tractable is, we're not done. And it, it's not totally clear exactly what it's going to take to get there. I mean, there's no existence proof. Nobody's done it yet. So we don't know what it looks like when it does work. So making precise predictions is tough, but there's a lot of low hanging fruit. We know how to make progress on all the things that we know are problems. And so it's a matter of turning the crank and executing and getting there.
Yeah. I thought I thought he did make some, strong kind of comments against LiDAR and HD maps. So when asked about it, he was saying, well, he did say the more important question is whether you have a fleet or not, right? The data is the bigger question. But he was saying he thinks LiDAR is not needed and other people will probably drop it, in reference to, a lot of these other
He said
players.
he thought some of them would probably drop it. And, and I think it's true. I think there are entities that will. I like his framing of the question of like more sensors versus less sensors. Like look at it generally, whether we're talking about sonar, lidar, or some other sensors that are going on, that there's a huge benefit to simplicity in the system. Like it's much bigger than people think it is. Like you want to keep things as simple as possible because you already have really complicated problems. So the question is, well, how many sensors do you need? And so the way you start the problem is, well, you have to have cameras, right? The road system is designed for cameras. Cameras are the one totally necessary component. Like there are no self-driving systems that don't have cameras. Like nobody's even thinking about it. Nobody's going to talk about it. It's a fool's errand. You're not going to take the cameras out. So you got to have the cameras. So now for every other sensor that you add to the system after that, you ask yourself, how much complexity does it add for what benefit? What's the cost benefit trade-off? And if the answer, the way he put it was, look, if it's not a big win, if adding that sensor is not a big win, then don't add it, right? It needs to be because any sensor you add is going to add a lot of complexity to the system, right? So if it's not a clear win, if you're not sure it's going to be there, don't use the sensor, which is obviously that's not what Tesla did. Tesla started out with sonar. They started out with radar. They started out with what I would have said was kind of the de minimis sort of common sense, generally accepted set of tools that you'd want to go into. And they ended up taking other sensors out because they had the experience of seeing the complexity and seeing the cost from the far end of having done it, and then deciding that they would be better off not dealing with the complexity, the overhead, what Andre called the bloat. Take those things out and let's focus on what's really important, which is the cameras.
Yeah. I mean, he mentioned that a few times, how like things like HD maps, whatever, all these other sensors dilute the team's focus away from vision, makes things more complex. And he kind of seems to really value this focus, laser focus on getting vision right. And it's, he made this comment that humans rely on vision, that vision sensor that we have as the most important sensor. And so it makes sense, that Tesla's doubling down on the vision sensor, making sure they get that right.
Humans cannot drive without being able to see. Like there are no blind people driving cars. Like that is absolutely critically necessary. You can delete almost every other sense from human beings and they can still drive a car. And you can take all their senses away and they can have pretty bad vision and still drive a car safely, right? Our road system is built for that. Like a very large fraction of people who drive cars on a daily basis, their vision is not great. It's not 20/20. Like it even corrected, it's nowhere near 20/20. some of them can't see very well at night. Some of them have other kinds of visual impairments, right? Like portions of their field of view, and they can still drive. Some people only have one camera instead of two, one eye, working eye, and they can drive. Our system is basically the road system, the world that cars operate in is overwhelmingly built to depend on vision, and nothing else is necessary, right? So you absolutely have to have vision, and there's nothing else that is absolutely necessary. So the minimum set of things that you can do to be successful is to do the cameras. And now if every other thing that you add to the program is going to make your vision worse, because it's going to take, I think it's easy to have this sort of mistaken impression that, oh, we can just add some more people and they'll work on that part and it won't negatively impact the vision. But that's not how it ever works, right? In any complex, interdependent technical development program, everything interacts with everything else. And so there isn't anything that you can add to the system that doesn't in some part detract from all of the other things, right? Whether you're taking focus away, or you're taking the best people away, or you're shifting emphasis or budget or whatever the deal is, just making an organization bigger makes the product worse.
Yeah.
Right. You always, like if you doing cutting edge development, a really important product, you always want to do your development with the smallest possible team of the best possible people. That's what gets you good results quickly.
Yeah, makes sense. It's interesting how like Tesla seems like to be pretty much the only major autonomous driving player that's doubling down on vision, like the way they're doing it. Like you have a lot of these other players that are using modal sensors. So even like Mobileye, they were, on vision, but now they're adding kind of, I think one of their suits has LiDAR. And same thing with like, you have Cruise and Waymo with LiDAR. And so you have Tesla, and I think that's one of the kind of unique angles from 5 years ago when they kind of Andre Karpathy first came, is they haven't veered from that kind of like vision is going to make it happen. He noted also like he's been there 5 years, and when he first got there were barely just like two people coding neural nets or something.
Yeah,
and now they have this like world-class team.
Under their training machine was under their desk.
Exactly. Yeah.
Which is like that's a pretty interesting insight into the status at that.
Yeah.
That was 2017, I guess, when he started, something like that.
Exactly. And he talked about software 2.0 moving from like kind of heuristic C++ code to neural nets. But if you think about it, this 5-year progress that Tesla has done is immense. Like from where they were 5 years ago to now, and how much they've built up in terms of team and expertise, data, and they're doing it in the real world for people to see it. You can actually drive the FSD Beta car right now. It's like tremendous. And I think the most bullish thing I got from that part was Tesla, in order to get where they've gotten in the shorter amount of time, they've had to learn how to move quickly. And the organization itself has that in it, meaning the DNA is move quickly, innovate, push hard. And that's probably one of the most bullish kind of signs for the future for Tesla's FSD program, is they've got that, move fast, and they've proven it over the past 5 years. What's your kind of take on some of this stuff?
Yeah, I agree. Like I stopped working in corporations because of all of the stuff that Andre says that Tesla tries to get out of the, people who measure their, not just their job satisfaction, but their progress, like whether they're accomplishing anything by like results at the end of the day, they all hate bureaucracy. Like everything that makes a system bigger, there are reasons to have that in certain types of organizations, right? But if you can find a way to do what you want to do without having all of that overhead, then you can just focus on making a really good product without, all of the sideshow stuff that goes on. And it's crazy frustrating. That's like, there are places where, when I started, if I wanted to design a printed circuit board, I could I could pick the vendor, I could pick out all the components, I could, get all the stuff ordered or ask somebody at the Nexus to do. And then 5 years later, if I want to use a slightly different, transistor of some kind on a board, I put in a requisition to the purchasing department, and 3 weeks later they tell me if I can have it. Now, I'm not even kidding. Like, I've been through this a bunch of times. Organizations get big, they get slow. They frequently have very, good internal rationalizations for why they need to be slow. Like, every single time you have something blow up, something goes bad, some customer gets embarrassed, you get some significant failure, companies add a process and then they never delete it again. Right. And 5 years later, the guy who's sitting on that process, he wants to go home and play with his kids. He's just, shortening one stack of paper and filling another stack of paper. I mean, organizations get slow because you add more people, more and more of the people that you add are not in a hurry.
Yeah.
They're there for the paycheck. Right. And so it's hard to, it is stunning that Tesla is as big as it is. And, it's pretty impressive how little they spend on R&D and how small their teams are, really, when you think about it. But even so, operating at that scale and not having a lot of bureaucracy, or having a guy who, like Andre said, who has the big hammer, who comes in and says, we don't need all that stuff. Just get rid of it. Focus on what's important, simplify. Like, that's super refreshing as a guy who's like sweltered under bureaucracy before, to like imagine working in an environment like that.
Yeah. My theory is, when you get a big organization going, most people, they would rather kind of have lots of meetings and hang out with people. They like the relational type of, it's not getting things done per se. It's like people have a lot of relational needs. They want to feel part of something inclusive. They want their voice to be heard, all this stuff. And I think if left alone, you get majority of people to set this culture where, like, I think Elon was commenting, there's like 10 managers he feels like to one engineer at Twitter or something. You get this culture of like everyone's voice is heard and everyone has a seat in the meeting, and you have all these meetings.
Very collegial.
Exactly. Versus this hardcore get it done, kind of this urgency of the relational, that's secondary. It doesn't really matter. We got to get this done. And it seems like Tesla has, or Elon especially, has captured that and has somehow, pushed, maybe with that hammer or something, but pushed hard enough where, the whole team understands that, that the culture isn't this, let's waste time by, hanging out and have meetings all day, but it's really one of getting things done. And that was refreshing, definitely, to hear, I think, with Karpathy too. Yeah. One other thing. So Karpathy had a lot of respect for Elon. He mentioned a few times that Elon moves fast. He makes big moves. He's a smart guy with a big hammer. He knows how to kind of steer the organization away from entropy. Also that he drives FSD a lot. I thought that was interesting, almost daily. Like, that was
I was thinking when I heard that, like, I wonder how many CEOs of other companies that are involved, that, like, if you asked them, like, how many hours a day do you drive the product? Do you use it? Do you do, like, I would bet that, if you ask, if you ask the CEO of Ford or the CEO of GM, right? Or even if, you went and asked Kyle Vogt, who's runs Cruise, right? Like, how many hours a day do you spend, in the car experiencing it, seeing what it's doing? But his answer is probably not going to be that many, right? I bet he doesn't spend a lot of hours sitting in the back of a cruise car, cruising around town, getting a sense for how things are working. And, the CEOs of Ford and like, I wouldn't be surprised if they've never used the product, or they've used it twice in demos, right, where the engineer showed them what was going on.
Yeah, it's interesting. That was one of my kind of fears, that Elon was getting so busy that like how much does he really have time to drive FSD Beta, to really test it out? But it's good to know that he actually is making a big priority.
And it shows that it's a priority. I mean, I really believe it's a priority for Tesla to execute well on this. Like, however long it takes, like, this is important. It's going to be a huge lever for the product. It's going to be one of the major contributions that Tesla makes to improving the world, is getting this product out there and getting it going. And knowing that he's not getting sucked into any of the, I mean, when you're the CEO, you get called into like every drama that happens at the company. The fact that he's able to maintain and focus on this, I feel like, is a really good sign. Yeah.
Do you think Twitter is going to be distracting to him? Like, it seems like to turn around that type of organization, I mean, it's 7,500 people, it's a lot of messiness. It's not like a clean organization either. I mean, there's so much drama and controversy, right? You make one change, you have all this outrage. I'm sure people are texting them like crazy, just like all this stuff. It's like, how do you make time for other stuff? I mean, I would imagine Elon would want to spend like 1 day a week on Twitter or something, but I don't know how he can just limit himself to that. It just seems like it
I don't
would,
know how he does what
yeah,
he does now, right?
that's
Like I
true. Yeah.
can't personally, I can't imagine being the CEO of one large organization. Like
Yeah.
I don't think I could do 10% of the job of running SpaceX. Like, I don't think I'm up to it. So like I apparently I have no idea what the man's limits are. Maybe he's got 50% spare capacity now that he's not sleeping on
Yeah.
the factory floor. It's frankly it's amazing. Yeah.
Yeah, yeah, that's true. Um, Last topic on Karpathy. So Karpathy's made some comments on AGI, or artificial general intelligence. And I thought it was interesting. He was saying one route could be kind of this internet kind of path, right? A lot of people are taking online, using the data that people have there. Another path is kind of more this physical world path where you have robots like Optimus interacting with humans in the physical world. And he was saying how it's uncertain, how we'll get AGI, but he thinks that Optimus is the harder but more certain path to AGI. And he kind of almost, I wouldn't say, he didn't say it outright, but it felt like he insinuated that Tesla is kind of in the running for, this event, in terms of the major players, in terms of who can contribute significantly toward AGI. It seems like in Karpathy's mind that Tesla is definitely one of those players. They're taking a different route. It's a physical, a robot route that he thinks is a legitimate route, and it might not get there first. He's saying it could be the internet route, but it's just interesting how he frames that problem. I'm curious, I wanted to ask you, how are you viewing AGI? Do you think artificial general intelligence can be reached through the internet kind of data route only, or do you think there does need to be a physical kind of robot or interactions
I
with the
am
world?
not like so I've heard there it's this the embodiment question,
Mm-hmm.
right? There since way before neural networks took off, like there's been a camp in the artificial intelligence space that really believed embodiment was important, and that we're working on trying to come up with ways to do embodiment. And so embodiment is this idea that that uh, that interacting with the world through a physical presence is either helpful or necessary. Like there are camps that believe like it's bare bottom necessary, like there's no other way to do it. And there are camps that believe it's useful, it'll be faster, right? But that you could do it other ways. And personally, I'm in neither of those camps. I I do not believe, and I believe embodiment could be useful, like depending on the approach that you take. But AGI, I'm always a little uncomfortable with talking about AGI because it's really poorly defined.
Yeah.
Like in the broadest sense of what the term means, like we're not going to make general intelligences because probably truly general intelligence probably isn't possible. Like every kind of intelligence is going to be specialized to some extent. A lot of people, when they talk about AGI, what they mean is something that's general in the same way a human is general. In other words, sort of, it's good at the same things humans are good at, which is a pretty good benchmark because the things we care about are the things we do, right? And we're
Mm-hmm.
impressed by things that can do the stuff that we can do, but can do it better. So then you have to ask the question, people will say, like a common definition of AGI is it does everything humans can do. And it does it better. Like superintelligence is being able to do all the stuff that humans do and being able to do it better than humans do. But that sort of imagines a form of being which is similar to a human being. Like uh, human beings, we're individuals, and each individual has a bunch of different capabilities, and we're all more or less the same. We all have more or less. I mean, some of us are better at some things than others, and that kind of stuff. There's a mix, but for the most part, human beings are pretty similar. You can't take a human being and divide them up into like 10 different modules that are just specialized on different kinds of things. And if you could, do something like that, you might find that you could make a better composer, or you could make a better cook, or you could make a better companion, or, all the different things you might want to be good at as a human being. That if we made something that was specialized to that, and if you had an infrastructure so you could switch between these specialized agents, that might actually be better. And in fact, like that, this idea is compelling enough that Marvin Minsky is kind of famous for saying, well, that's what humans are. They're a collection of different specialized modules. That opinion, that theory isn't as in favor as it used to be, but it's a nice framework for kind of understanding this. Like when we build AIs, they don't need to operate on the same time frame that we do. Like when Facebook or Google builds an AI, like when it holds a conversation, it's not one-on-one with a person. It'll be talking to 10,000 people at the same time, just like their Google search does. So the place I'm going with this is like AIs, they're only going to be like us to the extent that we try to make them like us, or that we want to, or there's value in making them like us. The natural progression for AI as it increases its capabilities, in my opinion, is going to be that it'll play to the strengths of machines, and it won't, and at some point those will be very complementary to what humans do and supplementary. Like they'll be able to do the kinds of things that we do, but it's not necessary to create value to do it the same way a human being does, right? Like you can do it other ways that are just as useful. And I think the natural progression, like if the point of AGI is to get the best utility out of AI, the short path to getting there and the natural path to getting there is not going to be trying to create things that are like people. I think we will create things that are like people because it's an interesting technical challenge. It's an easy thing to understand, and there will be utility in doing those kinds of things. But I think very few of the powerful systems in the world will be doing that. Like we won't have an AGI weatherman, right? We got a supercomputer that simulates the weather. That's a better way to do it, right? That's a machine way of doing a thing that you might want, a human to do. So, and it creates value. And I think we'll do that kind of stuff. I think we talk about AGI because it's an interesting and useful benchmark to talk broadly about the capabilities of AI. Like once you start being able to do something better than a human does, you start to create a kind of economic value that isn't accessible otherwise. I mean, it's one thing to be able to do math really fast, but it's another thing to be able to do novel math that no human being can do and solve grand challenges and whatnot, right? So there are advantages to crossing these superhuman thresholds, and that makes that a useful benchmark to talk about. But it's not, it's just that. It's a talking point. Like and there are people who specifically say they're working, like John Carmack recently said he wants to work on AGI, specifically as a problem. I do think there are lots of different ways. Like there's almost an uncountable number of ways to build really great, useful AI from different aspects. And which ones, the way it ends up getting done will be some of it will be coincidence, and some of it will be path dependency. Like we'll build on things that have worked well for us before. Some of it will be serendipity, and some of it will be very intentional, right? But for the most part, it's not going to be people sitting down, drawing a diagram and saying, this is exactly how to do it. And now we just need to do these different parts because we don't know how to do it. And there isn't like one agent which is going to solve all the economic needs that we want it to do. So that said, I think robots is a pretty powerful way to develop a lot of super important capabilities that will be useful to all different kinds of artificial intelligences that we want to have in the world. And that is a major contributor to AI. Now, Tesla, it's pretty likely that as we make progress towards AGI, that one of the things that we're going to find is that scale matters and having lots of data matters, especially in the early days. Like most technical things, like the first few times you do them, they take more resources. And then after a while, you get better and it takes less resources. You can do it faster and better. But the first attempts take more resources. And I think Tesla is very likely in the next few years to be one of the best resourced entities on the planet. Like, a few years ago, you would have said, if we talk about resources, you're going to talk about hyperscalers, Microsoft, Google, made people who have really, really big data centers and who have a dedicated group of people who are working on this problem. If you thought that like technical chops were the most, you might have looked at, say, DeepMind or OpenAI, who have fewer resources, but in certain respects, they have better talent. As things keep going, the resource part of it is going to become more important for the reason that Karpathy said, because scaling is going to matter. We're more likely to get there quickly if we pick simple, powerful techniques that scale well. And to scale well, that means you need a lot of computers. So whether it's Tesla going out and buying a lot more GPU clusters for training, or whether they get Dojo working and all of a sudden they have, 100,000 GPUs worth of capacity, that kind of resource, plus people who've been working on real world AI problems, those are going to be super important capabilities. And yeah, they will absolutely put Tesla in the running for being one of the entities that brings us home.
Sure. All right. So I want to segue off of this, what you're talking about here. So we've got this real kind of physical world, and you have Tesla, starting out with their cars, now trying to get into robots, getting a ton of data because you have video, which is just, massive amounts of data. And they seem to, at least Elon seems to think that Tesla's in the lead, or, the leader of real world AI. I'm curious, as Tesla kind of continues down that path, and you note that, the humanoid form is one type of form. It's not the only form for robots or AI. Do you think, though, Tesla
It's just the best one?
Yeah, it's the best, let's say, generalized form in our world, because so much stuff is built for
the human world,
humanoid form, right? Yeah, exactly.
Where we measure economics by human values. A human form is its best form because of its generality.
Exactly. So, but the question is, as Tesla makes this, generalized humanoid body, they're going to learn a lot of stuff where they could make a lot of different specialized robots for specialized tasks that do a much better job than, let's say, a generalized humanoid robot in doing those tasks. Do you think it's wise for Tesla to veer off, in some senses, to build those specialized robots as well? Or do you think they should just double down and just focus only on Optimus as their kind of main robot and just kind of ignore, other forms of robots?
Like, my metaphor for this would be like, look at the cars. Like, Tesla's not doing a van right now because there's a lot more value in making more Model Ys right now. And you have to build a lot of Model Ys before it makes a lot of sense to build a van to try to go after those other things. I mean, vehicles, to a first approximation, you can, there are special cases, but when there were only Model S's, people just bought Model S's and they were pretty happy with it. And then the Model X came out, and all of a sudden, there's a camp of people who now they want to do the Model X. The 3 shows up, and now a lot of people who would have bought a Model S, well, now they're buying a Model 3 because it fits, right? But they could have used a Model S. It's not as good. It costs more. Maybe it's too big. Maybe there are other things about it that you don't like. The robots, having one really general purpose thing that you can build at scale, I think that really is the way to start out. And that is the emphasis you get. And at some point you add variety, because the relative disadvantages of reducing the scale that you build your first one at, in order to, have something that's more optimized. Eventually you get to a point where it starts to make sense to make the second one, the third one, the fourth one. And like the cars, I think that happens after you get to a pretty high scale. So my guess is that Tesla, when they're building a million Optimi, then maybe it's time to make some variant that's specialized for some other kind of thing, right? But as long as there's lots of demands for Optimus, and you can satisfy that and scale up and drive the cost down and gather more experience, and put all of your wood behind one arrowhead to make fast progress, I think that's a good way to go, personally, right? I think that's correct. Now, there are companies that will find it more profitable at the individual level at the individual unit level to make lots of different ones, right? that are more specialized to some particular task. But I think if what you want to do is create a revolutionary product at real scale that makes a really big difference in the world, then you have to put a lot of effort into getting to scale. Like, I think that's really important. And once you get to scale, then you start thinking about other things. But getting to scale is much harder to do on 10 products than it is on one.
Yeah, that makes sense. I mean, just focus, double down on, the core product, get to scale, and then from there, you can satisfy maybe other segments if you want to. Karpathy, last kind of comment, like when I was listening to this interview on Lex Friedman, it kind of struck me like every time I hear Karpathy speak, he's very articulate. He's like he explains things kind of clearly, level-headed, and I kind of miss him as part of the Tesla AI team and all that. I wonder if like Tesla could do something where they could hire him as like their AI ambassador or spokesperson or something, someone to interface with, I don't know, the public or the world or something. That's the only thing. Tesla's so hardcore just getting things done. That seems like a extraneous, kind of role of it. Yeah, it's interesting.
There are a lot of different ways of looking at Tesla's, what public facing stuff. And one framework that I like to use for thinking about this stuff is words are just words and actions matter and results are what count. So we're going to do our speaking through the results that we get, right? And because, talk is just talk, right? And we see this because you see all of these completely worthless or actually counterproductive companies that have incredibly good PR, right? And they do a really great job of selling themselves, right? Whereas, if you actually look at the results of what companies do, like what is really important, it can be harder to see what's going on. So there's a component of that. Yeah, we're just going to do what we do. And then you can look at the results. And like, if you like the car, buy the car, recommend the car to your friends, or if you like the price point of our solar system and you think the service is good, then buy the solar system and recommend it to your friends, right? Like that should be it, right? That should be how you evaluate us, not on whether or not we say all the right things in a television ad.
Mm-hmm. Yeah, makes sense. All right, James. So I want to segue into part 2 of our kind of talk here. So first part, I wanted to just give kind of broad strokes on Karpathy's interview, but also kind of these more general topics. But this part 2, I want to dive into the specific release notes for Tesla's upcoming FSD Beta version 10.69.3. And you noted on Twitter that they had some big improvements. So I wanted to go through this point by point. There are 15 different points here. It's a little technical for those who fade off. Don't worry, no problem. But for those who are into this technical stuff, this is a good chance, I think, to get an interpretation, layman's interpretation on what some of this stuff means. So let's go to the first release note point here. So Tesla says they've upgraded the object detection network to photon count video streams and retrained all parameters with the latest auto-labeled datasets with a special emphasis on low visibility scenarios. All right, can you explain kind of what's going on here?
Yeah, so the photon count video, when they started doing this stuff, they were taking the cameras were feeding an onboard image processor that produces like this condensed, kind of cleaned up signal that the neural networks work on. And then over time, they started discovering that they were losing some information in that process that might be useful to the neural network. And so they switched to taking the raw camera data as it comes off the camera. And instead of having the signal processor clean it up and compress it and do things that initially seem like they're really valuable, they stopped doing that. They just took the raw data in. And then because the content of the data changes, you need to retrain your neural network. I mean, first of all, you have different data, and so you retrain. But now there's different strengths and weaknesses in the data. Like, for instance, it might be noisier than it was before, might have a different frequency response. The colors might be different, and so you have to deal with all that kind of stuff. So they first started talking about this like 6 or 9 months ago, where they started going to photon count, or essentially the raw camera inputs. So one of the things you get from the raw camera inputs is it has higher dynamic range. And dynamic range is really useful in situations where there's small amounts of detail that pre-processing the video might cost you, which turn out to be really valuable to understand what's going on. So for instance, say you're driving in fog, right? So you're driving in fog. It's not dark fog, it's daytime, but there's fog, and you're trying to make out the outline of a car in the distance. Well, most of what you see is fog. And then the outline of the car is slight variations in the whiteness of the fog as you go. And so that's an example of the kind of thing that, like, after you process the image, the car's gone, right? And if you take the raw stuff in, then you can do that. And so they specifically called out low visibility situations here, which is why I mentioned that. There are low visibility scenarios where either noise filtering is costing you detail that could be useful to the neural network. Like if your neural network's big enough, if it's got enough data, then it can see through the noise and it can pull out the details that it needs. And so essentially moving away from the compressed stuff to the photon count videos, it indicates that the neural network's doing well enough that now they have to go further, right? It indicates a certain level of maturity. Like, to get better, we need to get closer to the raw data. And so they're doing that with another network. So they've been doing this with some other networks in the car. This is a new network that they added it to. One of the things I thought was interesting about this note is the amount. So essentially they improved the architecture. So they changed the architecture when they switched this. The architecture of the neural net is like how many neurons you have and how they're connected together. And then they retrained it. So you retrain it on all new data in order to do this stuff from scratch with a lot of additional data. And then, of course, and at the end of the day, they get better numbers out of the thing. So it's a pretty significant amount of work to take what is one of the major kind of central critical capabilities of your system, this object detection network. It has hundreds of different outputs that the system uses in many different ways. So like, building a replacement for that, which is superior on all of those things in all the different situations, is a big piece of work. And it suggests that they're probably getting pretty substantial, because it wouldn't be worth doing if you weren't going to get a big payoff, right?
So are these two, so you talked about the second kind of release note, improved architecture for better accuracy and latency, 20% lower velocity error of crossing vehicles, and improved VRU precision by 20%. So are these connected? Is it the photon count update is connected to this architecture kind of improvement? And then
so
the results?
when you do the photon count update, when you switch from the pre-processed video to the raw video, you have a bunch more information, but you also have a bunch more stuff you don't want. So you have to add a lot of capability. Like the neural network needs more data to learn, oh, this is noise and I can ignore it, right? Like, not because previously the ISP might have been taking noise out. And so the neural network didn't have to learn to do that itself. All the stuff that the ISP was doing that was creating value, now the neural network has to learn to do all that stuff for itself, right? But now there's all this other data also coming in. And to take advantage of that, you also need more capability. Because like to the extent that your neural network was properly sized previously, now it needs to be bigger because you're asking it to do more and you're giving it more data, right? So all this stuff involves getting bigger. Now, sometimes when you get bigger, you just scale up, although that's kind of uncommon. Usually when you get bigger, there are certain parts of the network that you want to make bigger. And there might be parts that you can make smaller because like they were dealing with something that was a side effect of what the ISP output was, and now you don't need that, right? So essentially the network architecture changes. Some parts get bigger, some parts get smaller. Now you've got a new architecture and you have all new data, right? Because now you're using the photon count data, you're not using the pre-processed data. So you retrain everything. And then the numbers they're giving us at the output, like, lower velocity error of crossing vehicles by 20% and improved VRU. Those are a couple of examples of concrete benefits that they're getting from having done all of this work.
Got it. Okay. So when you're saying that, okay, they upgraded the object detection network to photo count video stream. So did they replace all of the video data that's feeding into this object network with photo count videos?
Yeah.
Photon count videos. Okay. So, I mean, that seems like a pretty major, because I'm assuming these are new videos, right?
Yeah.
Yeah, so they're having to basically retrain the
Yeah,
whole
we
network, right?
mentioned this before,
Yeah.
and I think we've talked about this a couple of times, but there's this perception, which is erroneous, that Tesla's got like this giant pool of data that they're just adding and adding to, and that it's the size of the pool that matters. The power of the fleet is your ability to like throw all that away, change your mind about how you're doing stuff, and regather everything that you need. Or to, I think the way that it was described on AI Day 2 is they have a lot of turnover. Like, they have this big cache of data, and some of it's useful and some of it is less useful. And they constantly have lots of new stuff going in. And they have this continuous process where they decide what's important, like, and what's not important. And so they toss old stuff out, they bring new stuff in. So when they want to do an architectural change, like, oh, we've been collecting all this ISP data and now we decided that photon counts are really important, we need photon count data. Well, they've got this giant fleet, they know they have all the triggers that they used in the past to gather that. They can resurrect those triggers, the ones that are important, push them back out to the fleet. Okay, now give us the photon versions, right? You can pull all that data in, and it's the searching and gathering capacity of that fleet, which is the power of it. It's not how much data you've collected in the past.
Got it. And it's probably
and so
faster.
This is an example of something that they can do because they have that fleet, right? If you're Waymo and all your training is coming off of this network that you have, like, well, I don't know that that's what Waymo does, but if you've gathered a ton of data and that repository of data is what you train on, well, you better have been right back when you decided what you were going to gather, right? Because now you're stuck with it.
Yeah, I mean, also the larger the fleet you have, so as Tesla's fleet grows, they're able to get that data faster, maybe more, diversity of cases. Interesting. I mean, this photon count video stream thing seems like a big step where there's potentially they're able to detect things that they weren't able to detect, especially they're saying low light, low visibility scenarios. Right. So do you think this is just the beginning of kind of the realized improvements by switching over photon count, that they'll be able to accrue some additional benefits as they kind of tweak things?
Okay, so it'll keep paying dividends. There will be things that in the future that they decide that they want to do, that they can do because now they're on photon video, that might not have worked previously when they weren't. But switching from, ISP post-processed video to photon count video, it's mainly about getting data that the ISP would have denied to. The ISP is kind of a filter. And the reason you put it in there is because you want it to filter out stuff that's noisy and distracting that you don't want to see. But the ISP is imperfect. It also takes out data that you do want to see. Right. And so, but taking the ISP out, it makes a neural network more complicated because now the neural network has to do what the ISP was doing in addition to everything else you want it to do. So it adds complexity to your system. Right. But the value you get for that is that you're getting everything the camera can gather, like the photon count video. That's reality as the camera experiences it, totally unfiltered. Like you're getting everything in there. If you let the neural network do the filtering, then the neural network can decide what's important and what's not important, right? It learns to do that, as opposed to an ISP, which is this hard-coded thing that was, that was probably designed with priorities that are not a perfect match to what the neural network needs to do.
Got it. All right. Third release note point says, converted the VRU Vulnerable Road User Velocity Network to a two-stage network, which reduced latency and improved crossing pedestrian velocity error by 6%. And then they say the fourth release point is converted the Non VRU Attributes network to a two-stage network, which reduced latency, reduced incorrect lane assignment of crossing vehicles by 45%, and reduced incorrect parked predictions by 15%. All right, so what's going on here? What is this two-stage network? What does it mean to convert?
So the term two-stage gets used a couple of different ways, and it's not totally clear which. I mean, two-stage, the core meaning is kind of obvious. Like you have two stages to a neural network. You produce some intermediate product, and then you run it through another stage of neural network to produce whatever the final product is. So there are various reasons you might want to have two stages. Like one reason that you can, there's an interesting version of a two-stage network where the first stage does what the basic neural network does, which is it makes a guess about what the right answer is that you're asking the neural, like, is this a pedestrian or not, or how fast are they working or not. And you can do a second stage, which is called an introspective network, that basically asks the network, now, why do you think that? Right? Like, why do you think it's this versus that versus all the other things that you could have said? And you can use that introspection to improve the original prediction by using it to weed out sort of there's the classic adversarial thing where, like, you put some tape on a stop sign and it doesn't get recognized as a stop sign or something like that. So if you ask the network, well, why do you think this was a stop sign, or why did you decide this wasn't a stop sign? And if the introspection network says, well, there's some tape here, right, that the introspection network can basically catch errors that the original network, that the first stage doesn't get simply from the training data by it's kind of evaluating it against a different set of criteria. So now, one of the things that makes me think that that might not be the kind of second stage that they're using is they talked about it reducing the latency, which you could get with an introspection network if it allowed you to make the primary stage a lot smaller. Like, maybe you get so much accuracy improvement from having the second stage that now you make the first stage a lot smaller, and overall the system gets a lot faster. But the simple version of that would always get a little bit, like, it would get better, but it would get slower. There are other kinds of two-stage things too. Like, for instance, there's another kind of two-stage where you have 2 or 3 different ways of evaluating something to get an answer, and each one has different benefits and drawbacks. And so one of the ways of going at a problem that has that kind of characteristics is you build 3 different models, which are called experts, and then you have another second stage that sits on it that decides, based on what it sees, which expert to trust, right? So that's another kind of two-stage. So I don't know which of these that it is. What it does tell us is they had these networks, the VRU Velocity network and the Non VRU Attribute network, that they re-architected with a new approach, and they got significant improvements in either the accuracy or in the latency.
Mm-hmm. Got it. Fifth point says, reformulated the autoregressive vector lanes grammar to improve precision of lanes by 9.2%, recall of lanes by 18.7%, and recall of forks by 51.1%. It includes a full network update where all components were retrained with 3.8 times the amount of data. All right, what's this autoregressive vector lanes grammar?
Yeah, so this is the language of lanes thing that we saw at AI Day, right? So they had this clever idea for trying to understand the connectivity of an intersection. And intersections are what they call that. And it may be that they use it in situations that aren't intersections too. But in where they found a way to frame it as a sequence problem, which they described with a grammar. And where the grammar is just basically, you have elements that kind of function like words or whatnot, and you turn the description of the intersection or the lane connectivity into a sequence problem. And now you can use a transformer, a language model core thing, and you can train it like a language model, which is pretty well understood. So they had been doing this already in the more recent version. So what they're basically saying is they changed the grammar for they sort of made this little synthetic language that describes how the different ways you could traverse an intersection sort of collectively describe the connectivity of that intersection. And it's, there are certain kinds of intersections that make sense and certain kinds of intersections that don't make sense. And so what doing the problem this way does is it gives you a pretty straightforward way to put what you think, the sensors can like look at the road and say, this is, they take the connectivity that they think they're seeing, they phrase it in the grammar that Tesla made up for this problem. They run it through the language model, and the language model corrects the grammar errors at the back end. And so the understanding you get of the shape of the intersection, like how it's all connected together, is more accurate. So there were particular problems that they were having that Ashok discussed after that part of the presentation that this approach solves. So this is still, it's a new approach. It's a clever adaptation of technology that was made for a different purpose. So unsurprisingly, they're discovering ways they can tweak it to improve it. And so the vectored lanes grammar will be the way that they take the connectivity of an intersection and encode it into a sequence description. They changed the way that they did this in some significant way that they don't mention here. And then they retrained the whole system. They basically probably, you could imagine they're looking at the thing and it's working pretty well. And they find this certain situation it's not working very well in. And they look at it some more and they're saying, there's this word that we have in our grammar and it's ambiguous in this really important way. And the only way to fix it is to add another word that disambiguates it, right? So they add that, but now you have to go back, and reformulate all of your data that way. So instead, what Tesla does is they go out and they gather a bunch more data, they encode it in the new grammar, and they push it through their new thing, and it fixes a problem and they get better results.
Got it. So I'm wondering if this might help this one problem I have. So I'm driving in Austin, and this happens to me quite frequently. I'm in a 2-lane left kind of turn area, and I'm on the outer lane. I'm turning left onto a street, but the street actually has 3 lanes I'm turning into. The leftmost lane is a left turn lane, and then there's 2 lanes. I should go right into this outer lane, but it actually, when it goes around and it doesn't go into the outer lane, it goes into the middle lane often. And so do you think...
And then you don't have enough time to do the lane change to make your next turn, right?
Yeah. Well, I have to... It's kind of dangerous because there might be a car that needs that lane because I'm on the outer lane. So, here's how you would apply this to that problem, right? Your car's approaching the network. Your car's approaching the intersection. Now, it has some map data that says some things, right? But the map data might not include, there are 3 lanes on this road exiting the intersection. Because, like, I've noticed looking at the stuff that some map data includes the number of lanes accurately to every intersection. Most map data doesn't include that level of detail, right? So as the car's approaching the intersection, what does the camera see? Well, it sees, the lane that you're in. It sees the shape of the intersection because you're making. You described yourself making a right turn, right? Or left.
So you're making a right.
Is a left turn.
Oh, so you're making a left turn.
Yeah.
But you're making a left, and then you want to get in the left lane.
No. I'm in a. It's a 2-lane left turn thing, and I'm on the outer lane. I'm turning left. I just want to stay in my lane and keep on the outer lane, but it doesn't. It goes into the middle lane because I'm turning into a 3.
So it moves 1 lane out instead of staying in its lane.
Yeah, because there's a left turn lane. Like there's 3 lanes that I'm turning into, or a street, and it doesn't keep that outer lane for me for some reason. Yeah.
Okay. Well, I'll describe it more generally.
Yeah.
Because the car always has a limited field of view, and you're kind of, especially as you're approaching an intersection, you're kind of looking at it edge on. Like you see this pavement kind of edge on because you're looking at it from a distance, and you see these markings, right? And the system, the previous way of doing this without this lane topology, this language of lanes network, it would look at this thing and it would try to map it in the vision space. Like it would try to say, this must be a lane, and this must be a lane, and this must be a lane. And sometimes you get ambiguity, like the road crests, or there's a bush blocking the thing, and it's not totally clear. Is there 2 lanes there? Or are there 3 lanes there? Or is this lane allowed to turn left or whatnot? As a human frequently approaching an intersection, even if you can't see that, it must be there. Right? Because you know something else about the thing, like, there are 3 lanes coming in the intersection. There must be 3 going out, or, that's a simple one. But there can also be like, if there are 2 lanes, if there are 2 left turn lanes, there are going to be 2 left turn lanes coming in the intersection and 2 left turns lane. And the inner one will never be able to cross the outer one in the left. Now, the outer one might be able to go straight or might not. Right? If you're just looking at the road markings and you're trying to figure that stuff out, the space of possibilities is a lot larger. But if you describe it in terms of what are legal, like what are legitimate ways to go through the intersection, the space of possibilities is a lot smaller. So what that allows the vehicle to do is it can tell what the nature of the intersection is when it's farther away or when it's only partway through a turn, right? It doesn't have to finish its turn, get completely set up, see all the lanes are in it, like, oh, I'm in the wrong lane, at which point you're already half a block
Yeah.
down the road, right? It's
Yeah.
going to see the right answer sooner and faster as the situation around the car changes. And what that leads to is just making fewer mistakes, because
Yeah.
you have more time to respond to and more time to plan what you're going to do, because you see the answer quicker. And so the language of lane sync, it's just a way of basically trying to describe all possible valid intersections in a concise form that the vision system can try to express, so it can check, like, this thing I'm seeing, does it make sense? Or, because humans do that. I mean, we know, there's certain things that make sense in an intersection and that don't. And because we have that sensibility, as we approach an intersection, we can make better, guesses about the things we can't see. And up until now, the car hasn't been able to do that very well. And by doing this, they're giving it that capability. And so this improvement is just improving that capability. They found a flaw in it, and they addressed it by these changes that they're describing here.
Yeah. All right. 6 point in the release notes: added a new road markings module to the vector lanes neural network, which improves lane topology error at intersections by 38.9%. So, what's a road markings module here?
My guess is they either added something that this kind of makes it sound like they added an architectural feature to the neural network. It's also, another possible interpretation is that they added a new label, which they probably would have said that a little. But in any case, they're now they're taking a different look at the road markings that they see in an intersection in order to interpret what the connectivity of the intersection is how I take this.
Okay. Got it. 7th, upgraded the occupancy network to align with road surface instead of ego for improved detection stability and improved recall at hill crest.
Yeah, this is a pretty big change. So the occupancy network right now, if you've seen the pictures, it's kind of like this, Lego world that gets stacked up. It's like everything that I don't know what it is, but space that's occupied, I'm going to describe it as these little cubes around the vehicle that are either filled or not filled. And okay, so right now, if you look at the occupancy network, like when the car turns a corner, goes over a hill or whatever the deal is, those Legos, they stay aligned with the vehicle, which means that when the car's attitude is changing, whether it, like, for instance, if the car is going over a hill, what happens is the whole occupancy network, because it's aligned to the car, it has to shift and stay valid. And what that means is there's lots and lots of updates. Like the occupancy network, if it's aligned to the car, then when you turn, the whole grid shifts, which means each individual frame as you turn is it's much harder to say what that should be based on what the previous one was. Now, what you'd like the grid ideally to be a fixed feature of the world that the car moves through, so that each frame it gets, even as the car's attitude is changing, it's like, you have the fire hydrant and it's made out of a bunch of Legos, right, over on the corner. And it's the same set of Legos in each subsequent frame, right? So that each of those frames is building your confidence that you understand it's a fire hydrant and it's in that location. If the grid shifts with the car, then the fire hydrant is changing, where it is as you move around. Okay, so they're not dealing with the car rotating laterally. They're dealing with the car cresting a hill or whatnot. So what they've done is, instead of having the Lego blocks line up with the car, they line up with level with the road surface, right? So the Lego blocks don't change as you crest a hill. And cresting a hill is a super important situation, because it's one of those situations where you can't see what's right in front of the car. Like, what's right in front of the car is really important for the decisions that you're going to make. Like, if you're cresting a hill and it's turning, right? Well, all of a sudden there's stuff in front of your car that wasn't, and your path has to change and whatnot. So cresting a hill is one of those times when suddenly you learn a whole lot of stuff just as you crest the hill. That's super important, and you need to bring all that stuff in. It doesn't have any history. So you'd like your predictions and your understanding to not change any more than necessary as you crest. So what they've done here is specifically they've changed the grid network so that it doesn't so that the attitude of the car doesn't affect it. The car can move through it and it can be stable with the world around it. Does that make sense?
Got it. Yeah, that makes sense. Eighth update is reduced runtime of candidate trajectory generation by approximately 80% and improved smoothness by distilling an expensive trajectory optimization procedure into a lightweight planar neural network. All right, what's going on
Yeah,
here?
so this is pretty brilliant. So distillation is a way of taking a big neural network and making a small neural network that's just as good as the big neural network. And the thing that you win from that is frequently, if you want to train a neural network to do something complicated, frequently the training process itself requires the network to be pretty big because you're training it from raw data. But then you get this thing where like, I have this big neural network and it works, but I'd like a smaller one that works just as well. And you can do this thing where you have the big network teach a small neural network to get all the same answers. Right. So you do a second pass where you train a second neural network. And what it does is you don't train it on the data the big one was trained on. It doesn't need all that. And it doesn't have to consider all the possibilities. The big neural network has already learned what it needs to know to do this problem. And so basically what you do is you train the small neural network off the big one. So this process is called distillation or knowledge distillation, because you're basically, the idea is that you build a neural network and it's a certain size, and part of the size is the bigger it is, the faster it learns, right? But once it's learned it's what it needs to learn, a whole lot of that bigness is no longer necessary because it's not learning anymore, right? So distillation is this process where you distill out what it learns and you get rid of the part that it needed to learn it, but which isn't actually relevant to the answer it figured out. Okay. And essentially the way you do that is you take a small neural network and you train it off the big neural network to do this thing. Now, they've actually gone a little bit farther than this. They had a process that had multiple neural networks and they had multiple neural networks, more than one, and it also had some heuristic code baked into it. Now, the result of all this is that you ask a question, and then the heuristic runs through a set of possibilities and uses a neural network to do these intermediate evaluations. But at the end of the day, it gives you an answer. So they didn't just take a big neural network, but they took a neural network with this other stuff in, and they ran the distillation process to convert that whole thing into just a neural network. So it became much lighter and much faster.
Got it. So what is this candidate trajectory generation? Is it just a different place? Is it more of a planning module of like what trajectory to take as for the car, or is it?
You know the intenticle when you're driving the car and you have the blue wiggly line that sticks out the front. Yeah. So that thing, so it's showing you the number one candidate trajectory as you're going along, right? Now, the neural network, it only shows you the number one candidate, but it also has 2, 3, 4, 5, 6. It'll have, and so when you see that blue line wiggling around a lot, it's because number one and number two are pretty close. Mm-hmm. And as they switch locations, it shows you a different one. So you see the line flipping back and forth. But there might be 10 candidates or 50 candidates or something, mm-hmm. depending on the situation that you're in. Like if you want to make a lane change and there's moving cars and you're trying to predict what they're all doing, you could change now slowly, you could speed up and move there. Like there's all these different trajectories you could potentially do. And one of the first things that you want to do is generate a set of good candidates that you can subsequently evaluate to decide what the best one is. Mm-hmm. So apparently what this thing is doing is it's taking that module, which previously was a neural network and some heuristic code to generate these candidates. And instead what it's done is it's distilled it down to a one-shot neural network that just basically looks at it and goes, boom, here are your candidates, right?
Got it. I mean, it sounds like a big deal because 80% reducing runtime. Yeah. I mean, it's a big, that's a lot of, that's stuff you can use for other things too,
engineers live for, right? Yeah. It's great to find something that's like, wow, I made it 10 times better. Right? Yeah. This is like a 5x improvement in speed, right?
Yeah. I mean, and that's the thing. They're always, looking for, there's limited amount of resources to run right in the car. So if you can save 80% runtime, it's like it opens up, a lot of other processes.
You can add more other stuff.
Exactly.
You can add. Right?
Ninth update here is improved decision making for short deadline lane changes around gores by richer modeling of the trade-off between going off-route versus trajectory required to drive through the gore region. What does this mean here?
Yeah. So that's pretty interesting. So we haven't seen them talk about going off route before. So okay, the way I'm taking this is, you have a route and sometimes you can't make the turn, right? For instance, in your example before, you want to make that left turn at the intersection you're coming up to, but if you're going to make the left turn, you got to do the lane change and then you get to make the left turn. And the downside of not doing that is now I'm going to have to route. I'm going to have to go around the block or whatever the deal is. So, so this is a pretty common problem around gores, right? So when you have limited time to make maneuvers on a lot of highways, you have gore zones that are drawn. Now the gore zone, you could cross a gore zone, right, to make your turn. It's not actually an obstacle. There might be some junk or some debris or whatnot, because it's not a road surface that people drive on a lot, but it's not like a hard obstacle. Like you're not going to get into a crash if you cross a gore zone. And a lot of gore zones they're kind of gratuitously long. Like, a lot of times when you come to a freeway exit ramp, there might be a little gore zone, but then they have this really long, straight, solid white line, right? And if you've noticed, the car doesn't like to cross the solid white line because that's part of the gore zone. Right. Mm-hmm. And as a human, you're like, why aren't you crossing the line? I'm going to miss my turn. Right. Mm-hmm. So now, so apparently the system before didn't consider, well, what if I don't make the turn? Like that wasn't part of the thing. And now it's like, oh man, if I miss this turn, I got to go 5 miles before I got another exit. Right. And so it's going to take that into account and when it decides like whether to cross the gore or not. Right.
Wow. That's interesting. Yeah. That's like pretty advanced stuff. Yeah.
I mean, like there are good reasons to not cross a gore. Like just in general, if your rule is ignore the gore zones or never, ever, ever cross the gore zones, you're going to go with option B, right? Because that's going to be safer. But human beings, you drive in LA, you frequently are going to have to cross a gore zone or you're going to miss your turn because that's just the dynamics of the traffic. It's really hard to avoid those kinds of situations. And so at some point, the car has to start entertaining like, okay, this is a good idea. This is a good place to cross the gore zone, or, this is a gore zone that would be okay. Like depending on the gore zone and depending on the situation that you're in, it may or may not be a good idea to do that. And one of the criteria for making that decision is, well, what happens if I don't, right? And one component of that is, well, how much longer is my route going to get? It's funny. I do a thing when I drive FSD where like my general thing is like, I let the car do, because I want to see what the results of what it does is. And there have been a whole bunch of times where, the car was trying to get off the highway and it couldn't get, it couldn't make the exit or whatever the deal was. But the resulting route is actually shorter than the route I was going to take, right? Like, Google calculated it and it went this way. And it turns out that once you pass that, you can get off at the next exit and approach the destination from the behind. And it's actually easier, right? So a lot of times missing your turn doesn't really matter, right? Yeah. And in that case, you don't want to cross a gore zone because it's not getting you anything, right? You don't want to try to squeeze in between two cars that are tight. Yeah. You don't want to take any risk at all if you don't get anything for it. But there are other times where you miss that. Oh, now you got to go down to the 57 and do the cloverleaf and come all the way back, and it's going to cost you 10 minutes. Yeah. And so at least taking that into consideration when you decide how much risk, how aggressive you want to be is a useful component to contribute to this.
Yeah, I mean, this is an interesting update because it seems like prior, like Tesla is saying, stick with the rules, basically, stick between the lanes and do all this stuff. But this is saying like they've progressed to this point where they're tackling problems where sometimes bending the rules or going outside the lanes is actually better or safer or smarter, and they're trying to figure out when those cases are. So it's really expanding, it seems like, the scope of how FSD Beta handles driving.
This is also like my general sense of the priorities are like, what can we address in this next update that will solve the most real problems that people encounter, right? And so incidentally, as a sideline to that, a lot fewer of the things that they're focusing on are, oh my God, we have to get this right or there will be a crash. Like they're not, we used to see a lot of things that were like pretty safety critical, like the accuracy of the, vehicle detection isn't good enough. Make it 5% better, make it 10% better, make it 30% better. And we saw that over and over again. And now we're seeing a little bit less of that. And we're seeing more of the effort go into these somewhat more complicated problems that are arguably about convenience or having a good experience, like not having a lot of jerk when you do an unprotected left turn is a lower priority than just doing it safely, right? So when they get to the point where they're like where they're focusing on doing it smoothly, one of the things that we're learning is, okay, they're getting to where they're kind of satisfied with the safety, right? And now they can start looking at other things.
Yeah, makes sense. 10th update is reduced false slowdowns for pedestrians near crosswalk by using a better model for the kinematics of the pedestrian. That makes sense.
So this was, we heard a lot of complaints about how, which incidentally I never experienced myself, but I live on a road where there are no sidewalks and people like to go walking in the morning. And so my car like goes through pedestrians, every morning if I go someplace. And I haven't really seen a lot of problems with pedestrians, but a lot of people have complained quite a bit about FSD either not stopping when it should because it's not predicting, or a lot more complaints that it's too conservative. It's stopping in the middle of the intersection for this woman who's clearly not trying to cross the road. So by improving your model of predicting what a pedestrian's intention is, then you're going to reduce those number. And so that was they described it as an unnatural slowdown.
False slowdown.
False slowdown. Yeah. So where, this happened to me the other day that I'm going through an intersection and there's a guy riding a bicycle up to the intersection and, my car comes to a stop. It's pretty clear to me as a human being, because what the guy on the bike is doing is he's riding on the sidewalk and he wants to ride up to the crosswalk. He's going to turn and go in the same direction that I'm going. He wants to cross the street, but first he has to get to the crosswalk button because he wants to press that button. Right. Well, I can see him rotating the bicycle, because you can't reach the button from if your front wheel is against the bike, you got to come up alongside the pole. So as a human, I see him and it's pretty obvious, like he's turning his bicycle because he wants to push the button. And I know he's not going to cross my path. But what the car sees is it's just looking at this guy's vector and it sees it coming right up to the curb, right? Because that's where the pole is. The pole is right at the curb. So the car stops, which if all you know about the bike is like, where is the driver's or where's the rider's head? And is it going to cross my path or might it cross my path? Well, then you stop. So having this better kinematics model, you say, oh, his path is shifting or he's facing a different direction. He's rotating, right? And so now I don't have to stop because the car can be confident that if you extend the arc of his trajectory, it won't cross our path.
Yeah, makes sense. It seems like some of this stuff longer term, I could imagine, the neural networks basically looking at the face of the pedestrian or the biker, seeing where they're looking, the expression on their face, just different things that, and even maybe in faces in people in cars or something driving, but like, it seems like something you could train the neural networks fairly, quickly, especially if you have millions and millions of data points, right?
That is totally, I don't want to say it's a solved problem. It's a problem that we know how to do. And for example, pose estimation is where you take a picture or video of a human being and you basically say, where are the arms and legs and how are they moving in time, right? Because from the pose estimation, you can say a lot of things, especially if you watch it evolve. They're walking with this person, they're looking down, there's all this stuff that you get from the body language. And there are really good neural networks out there that can just basically look at video people and do really good pose extraction. And from the pose, you can determine a lot of better intent. Okay, so why isn't Tesla doing this right now? Because they haven't gotten to it.
Yeah, exactly.
Right? Like it hasn't made the cut. So they will. There's that or something equivalent will happen. The other thing about gaze estimation, anybody who owns an iPhone with Face ID knows that computers can do gaze estimation really well. You don't look at your phone, it doesn't unlock. And it's not some special magic trick that you can only do at 12 inches. A computer can tell from as far away as you can identify a human face, whether it's looking at you or not.
Yeah.
Like that is not like some fundamental research problem. We totally know how to do that.
Yeah.
But you don't add it to the car until it gets on the list of things that you need to solve to continue improving the experience. So as long as there are other things that are more important, you don't get to it.
Yeah. I mean, I could see eventually, like, because the car has super processing power, you can look at multiple pedestrians across, multiple views, and you'll see their expressions, their movements, and be able to predict pedestrians' movements much better than a human could when humans are isolated just mostly to one, view, one angle. It just seems like it seems to be much better.
I mean, for one thing, humans are pretty easily distracted by other people, right? Like you can be, if you're, you pull up to the intersection and there's a funny looking guy in a costume over here, right? And now you're not looking at the person who's in the way of your right-hand turn or whatever, or there's a pretty girl, or there's, a cute, set of school kids, coming with their nice little uniforms or whatever the deal is. Like, looking at human beings is actually a weakness of humans because we don't focus on what's really important in that situation.
All right, James, a slight digression here. So I had this idea, a business idea. I was like, I'm taking out my dog to go pee. He's like 13 or 14 years old. He's a small dog, like 4 pounds. So he has a small bladder. I'm having to take him out like 5 times in the morning and just like throughout the day. It's just crazy. I was thinking, if we invent a device, you stick it on the dog, right? And basically use AI to track, the dog's movements, but also all dogs. And you can detect when they need to go pee. I guess you'd have to have some result of like, inputting some accidents or whatever, but you could see the changes of their body movement when they're trying to, they're getting, and then you can alert the owner that the dog needs to go pee at the right time. I mean, that seems like, yeah.
If you can look at your dog and tell, like if he's got body language or movement and that kind of stuff, which is for you a tell, there's probably a pretty good chance that a neural network would be trained to do it. Now, an interesting question is like, are they common across all dogs? So that you can gather lots of data and make a product and sell it to more than one person, right? Sure. It's so like Apple just recently added the sleep monitoring thing to which, like, if you don't use it, like, I really recommend it. It's been really interesting. It can tell like if you're deeply asleep, if you're dreaming, if you wake up, it's got these different stages, and it monitors the thing throughout the night, and it helps you like develop habits so that you sleep better at night. Yeah. So, the watch can tell if I'm dreaming or not. Right. It's really good. Like, I don't know what the algorithm, like it's going to be some combination of how you're moving around, how fast your respiration is, because it can figure out that kind of stuff, maybe what your heart rate is. But, if they can slap a watch on people and tell if they're dreaming, as opposed to lying there awake, staring at the ceiling, right, which is the other option, like, that's pretty subtle. So I imagine the dog thing is probably not so subtle.
Yeah. All right. 11th update here is added control for more precise object geometry as detected by general occupancy network. It's a little vague, right? I mean, control for more precise object geometry.
The insertion of the word control there is a little bit interesting. I mean, the rest of the thing seems to suggest that they are precision is also kind of interesting, because when you talk about the occupancy network, precision is a function of how fine the network is, like how small the boxes are.
I mean, could it be that
one way of reading this is they're adding some small boxes close to the car?
Okay. I mean, could it be that it's more the second pass where, you have the occupancy network, but then you're focusing on certain parts of it for more precise, geometry?
We might be reading this slightly. There's another reading, which is they added control for the more precise object geometry as detected by the general occupancy network, which the way you would read that is like, they're getting this more precise geometry, and now they want to take advantage of it by changing the vehicle, because control is vehicle control decision, planning or whatnot. So basically this might be, oh, we're getting better estimates of like where the the tree is adjacent to the road that sticks out, or we're getting better data on this kind of stuff, but we hadn't up until now taken advantage of it by changing the control algorithm to respond to that. So that might be what they're saying. This is a little vaguely worded.
No problem.
I would probably go with that interpretation right now.
Got it. Number 12, improve control for vehicles cutting out of our desired path by better modeling of their turning lateral maneuvers, thus avoiding unnatural slowdowns.
Yeah, so this will be really nice to have. So, if you're FSD, you're driving downtown and somebody pulls out of you because they're going to turn into the grocery store, and they slowly wander out of your lane or whatever the deal is, and your car comes to a halt instead of like, so the car's gotten a lot better because it now has offsetting behavior. It used to be, it wouldn't change out of its lane. So, if grandma is making a left turn and the back of her SUV is sticking 2 feet into your lane, the car, for a long time, it wouldn't like move over and just go around grandma, even if the other lane was in. Well, now it'll do that. It's been doing the offset thing, but you can do even better on that by basically doing better trajectory prediction about what's going on, like understanding that based on the way that the vehicle is rotating, it is actually going to make a left turn. It's not just pulling in, it's not just pulling off the lane, and it might pull back in or whatnot.
Got it. Okay. That makes sense.
So that gives them more confidence to be able to not slow down in situations which previously would have been ambiguous.
Mm-hmm. Yeah, it's interesting. It's like some of these updates, they're important updates that really improve like certain cases, but they are
this I hit all the time.
Yeah,
like there's a road I drive on all the time where you're driving down this shopping district, and it has one of those those double dotted yellow sort of left turn lanes that you can pull into so that you can pull into driveways. And a lot of people just, they kind of pull halfway into it, because if you're a human being, you just drive around the back end of the car and it's not really a big deal. But up until now, FSD hasn't been happy about sort of cutting corners and going close in those kinds of situations. Yeah. And it's gotten better. Like they've added behaviors and predictions where I get fewer of those than I used to, but it still does happen sometimes. So I'm anticipating that this will reduce the number of times that my car stops when it doesn't need to.
Yeah, that's going to be big. 13, improve longitudinal control while offsetting around static obstacles by searching over feasible vehicle motion profiles.
Yeah, so an interesting question is whether they're talking about the vehicle motion, feasible vehicle motion profiles. It could refer to the other vehicle. Oh no, this is static objects. Okay, so basically longitudinal control is acceleration and braking. Okay. And so basically they're getting smoother acceleration or braking while they're offsetting around static obstacles. So a static obstacle is like, you're driving through a pedestrian crosswalk, and it's one of those ones that has a pole, that warns you that it's a pedestrian crosswalk, and your car has to move slightly around it, or maybe it's a cone in the road or something like that. And so instead of just having a rule, like in this case, I can go this fast. Instead, what it does is it looks at the trajectories and it sees what a reasonable velocity is for the alternate trajectories around that object, with the goal of not slowing down if you don't need to.
Got it. Okay. Number 14, improve longitudinal control smoothness for in-lane vehicles during high relative velocity scenarios by also considering relative acceleration in the trajectory optimization.
Yeah. So apparently up until now, I'm a little surprised that they weren't considering acceleration. So, when you are maneuvering relative to another vehicle in lane, your positions matter and your relative velocity matters. But another thing that matters is whether that relative velocity is increasing or decreasing, whether it's changing, right? So for instance, you pull it, you're in a lane and you're gaining on the guy ahead of you. Like maybe you're driving along and somebody has pulled into your lane. Like this would be a canonical example, and they start accelerating away, right? So initially they pull in front of you, and the car, the FSD sees that they've pulled in front of you and looks at your velocity and looks at their velocity and says, oh, I'm closing on them. And then it's like, I better slow down, right, to reduce that kind of stuff without taking into account, oh, they're accelerating hard. Like, you don't need to slow down as much as you would have to. So apparently now they're going to take that acceleration into account also when they decide, like in that situation, how much braking you need to do to maintain a safe distance.
Interesting. That makes sense. Number 15 and the last update, reduced best case object photon to control system latency by 26% through adaptive planner scheduling, restructuring of trajectory selection, and parallelizing perception compute. This allows us to make quicker decisions and improve reaction time.
Yeah, so this is a basket of optimizations that they have done to basically reduce latency, right? And give themselves more time to make decisions or be able to make decisions faster. So, so the adaptive planner scheduling. So the FSD itself is about 100 different tasks, and where each task has an input and it does a certain amount of processing and it produces an output, and that output might be used by some downstream thing to make a decision. Or so they use an adaptive algorithm that basically schedules these tasks so that the downstream tasks run when their inputs are available and soon enough that you get their output in time to make the decision that you need to make. So there are some tasks that take variable amounts of time, and different tasks have different priorities. So apparently what they've done is they've gone to an adaptive planner scheduling that takes into account, like, what do I need to know in the next 10 milliseconds, and then and essentially rearranging the schedule in order to be able to get that, understanding that some kinds of some kinds of these planning tasks can vary a lot in terms of the amount of time. It looked like they weren't taking that into account before. So then they restructuring of trajectory selection. So this is, previously they told us that they made this big change to trajectory, to the trajectory candidate generation process that reduced the compute and latency on that by 80%. So this may be a downstream consequence of that. It's like, oh, we got this thing, now let's take advantage of it. And then parallelizing perception compute. So parallelizing stuff typically means that where you used to have something that was a block that, of code that was connected together, and you did A, B, and C. Parallelization is a process of like breaking it into pieces that if they don't have dependencies, they can run simultaneously on different things. So this might be splitting things, so inside the FSD chip, there are two neural network compute units, and there are also a bunch of cores and a bunch of GPUs. So depending on what resources you're using, you can run multiple of these things at the same time in a non-contentious fashion. And there's also two chips, right? So you could decide you're going to run part of it on this, you could break something up into pieces, run part of each of it on two different chips and get your answers sooner rather than having to wait.
All right. Makes sense. Man, this update actually feels like a pretty chunky update. I mean, for a 10.69.3 update, it feels like it deserves its own, 10.7 or 10.8.
Elon was cracking that it's really, that the .3 was not really a point update. It was really a major update. And it does kind of seem that way. I mean, a lot of these, just looking at the text, a lot of these, changes, like in terms of results and the effort that it takes to do them it's kind of on the scale of what we saw with 10.69 when we first got it. There were a couple of things we got in 10.69 which felt really big, but this has also got a number of biggies in here. I like the fact that, a lot of the previous updates we got, it would say, oh, we got a 40% improvement in that, or we got a 30% improvement on that. But because there's 100 outputs, and because the way the accuracies interact with one another can be kind of hard to understand how it's going to impact your experience, you start driving the car and did it get better? I'm not sure. What situation was it going to get better? And accuracy is that kind of thing. Like, it does affect a lot of stuff, and it is really important. But you just kind of got to drive it and see if it like feels better than the previous one did. Whereas these, they're a lot more concrete, like I'm definitely, when I'm driving down Foothill Boulevard, I'm going to watch for that left turn pull out thing, and
Yeah.
I'm going to be
Yeah.
cued in to see whether or not going around vehicles or going around static obstacles is working better now,
Yeah.
in terms of the longitudinal control. Like, is it not braking? Am I not getting as much jerk? Is it able to maintain its velocity? Am I comfortable?
Yeah. Yeah. I think, yeah, this stuff is super helpful because I remember a few updates before they're talking about kind of lane markings and retraining, getting improvement on the lanes. And one of the problems I was having was out of my kind of neighborhood, I would take a left turn, but then the lane would split into two lanes, and the car would stutter, kind of like wouldn't know which lane to take, and then I don't know, it was weird and almost stop. And I noticed the recent updates, it kind of solved that. It just knows which lane to go into. I think it's much more confident in detecting, the lanes. So stuff like that. And then also, I think with this update, I'm looking forward to see if it'll keep the lane around the corners better, like a left turn lane or something. Hopefully we'll see some improvements with that as well.
I would like that too. Like
Yeah.
so we just did a 5-day trip where we drove. We went through Zion, and we drove up Escalante, which we like, in
Nice.
Utah. So I had 5 solid days of like watching FSD drive the car, and and for the most part, like, it was beautiful. Like, the car drove all the way through Zion, it drove all the way through Bryce. I never had any interventions, and it was super comfortable. And which, on that kind of thing, is nice, because as a driver, you're there for the scenery, right? It's nice if you don't have to stare, intently at the car ahead of you, or if you're
Yeah.
on a windy road, if you're pretty comfortable that the car can stay in its lane, and you can actually see some of the stuff instead of being laser focused on the pavement. And I had one critical intervention, like, I think in 4 days, and it was when the car tried to do a left turn and wanted to change lanes in the middle of a left turn, the thing that you were just describing, which was, and it was kind of one of those, like, we had 5 days and we did all this stuff, and then I come back to LA and you can't make a left.
uh, yeah. Yeah. Fascinating. It's it's definitely fascinating to see the progress with each update. Yeah, I wanted to thank you on behalf of probably the many people who watch, because this stuff is immensely valuable, because a lot of times I think the technical language is out of reach for a lot of people. It just is confusing and complicated, vague for those who aren't in that field. But I think talking to you, it brings it down to more kind of easy to access, concepts and
These
ideas.
notes they're pretty easy to understand in general. It's really rare for them to come out with notes where, like, you really got to be a specialist to understand what's going on. But I agree, the technical vocabulary is just daunting, right? If
Yeah.
you don't get exposed to it.
Yeah.
Probably most people can figure this stuff out by thinking about it and doing some Google searches. But if
Yeah.
we save them some time, then that's great.
Yeah. Yeah, definitely. I wish there was like a virtual tip jar for you or something. People could give tips or something.
I don't need the money. I
Just
appreciate the thought.
definitely. I feel like that almost every talk.
Oh,
Very, very
wow.
thankful. Yeah, awesome. All right, James. Wanted to thank you, and we'll definitely talk again. We still need to do, I think, our last Tesla
Yeah.
AI video on the second part of FSD. So
Yeah, it
I'll
starts
bring
with the
something.
language of lanes thing. I was
That's
thinking
right.
we hadn't got a chance to do that yet, but
Yeah.
we'll have
So
to. I know you were traveling, right? So we needed
I'm
to.
actually I'm starting to travel next week, so maybe we should actually try to figure something out this week if you have time. Yeah.
This week won't work for me,
Yeah. Okay.
unfortunately.
All right. Maybe. Okay. I'll talk
But, well,
offline. Yeah.
we'll
We'll
get to
figure
it at
something out.
some.
Yeah.
I
Yeah.
mean, it's only been a few weeks since the event.
Yeah.
It's not like we're super late.
That's true. All right. James, take care. Have a good night. We'll see you, man. All right.